So today we're going to get into the third part of our building a product catalog. Today we're going to look at understanding how to manage and interact with our data. In the first part of our presentations, we looked at how to understand what makes up the product catalog, and we walked through a use case for designing a generic real-world product catalog. Within that lesson, we began by defining a product catalog as a place to store information about products. We then went on to define the different parts of a catalog, such as the product, the category for your products, the images for your products, and vendor information to go with the products. We then wrapped that lesson up with an understanding of how the catalog components relate to one another, the different relationships, the one-to-one, the one-to-many. We then went on in the second lesson, we looked at understanding the ways to store our data. In this lesson, we focused on understanding the different types of data files we can use for storing or capturing our product data. Next, we kind of demoed and looked at different applications that you can use to create and maintain these data files. Data files being the CSV files, the fixed width files, or the Excel files. And then that lesson, we wrapped up and looked at replacing the data files with the database. So we actually went through and looked at the SQL that was necessary to create our database and the database tables that related to our product catalog. Which brings us to today's lesson, where we will expand on our database knowledge by looking at the different ways in which we can manage and interact with our data in the database. We will also be creating a very simple Java Spring application that will interact with our database. I was going to do a very elaborate application, do it true object-oriented, and I decided for the scope of this lesson, I'm going to keep it very simple, and we'll get into a deeper dive of the application in the next lesson. So continuing our discussion from the last lesson, we now have a database with some tables in it. As of right now, these tables are useless to us because they have no data. Therefore, we need to look at the different ways in which we can go about getting our data in and out of our databases. First, we will start by looking at how we can import data from a data file, like a CSV, fixed width, or an Excel file, into our database. Then we will cover how to use structured query language, or SQL for short, to write scripts to interact with the data in the database. Next, we will briefly cover some third-party applications so that you can simplify your database interactions. Finally, we will build our own application to interface with our database. So what are some of the options to pushing our data into our database? Well, for starters, we can use call-level interfaces, or CLI. These are application program interfaces, or APIs, and software standards to embed structured query language code into a host program. These are typically provided by the database software or the database companies themselves, like Oracle, MySQL, Postgres. These typically run on Windows command line, Linux terminal commands, but anywhere from a command line to actually submit your SQL commands either directly to the database or do it through the terminal window interface. Next, we have the database import-export definition tool. This tool can be used for a number of different files as long as the organization of the columns in the files match the columns in the import-export definition window. For example, when importing data using a CSV file or fixed width file, the tool can be used for mapping the columns to the corresponding table columns. So if you have a 5-column table and you have a row in your CSV file that has 5 values separated by commas, you can then map them to the corresponding tables. Now, if it's pretty straightforward where they're in order, that's great. If they're not in order, you're going to have to map, okay, record 1 goes to table or column 3, and so forth. So it's a form of mapping your files to the actual tables. Alternatively, there are many third-party applications on the market that offer users more of a turnkey solution to simplify the task of importing the data files into the database. However, in principle, these tools are similar in functionality to the database import-export definition tool provided by the databases. So typically, you will use about 4 SQL commands for managing most of your data in a database. These commands are going to be your inserts, your updates, your deletes, and your selects. The insert statement is used for inserting new records into a table. The update statement is used to modify existing records in the table. The delete statement is used to delete existing records in the table, either by a single record or all records or multiple records. And the select statement is used to select data from a database, and the data return is stored in a result table called the result set. So I'm going to take a moment now and jump out of the presentation, and we're going to go look at the SQL for our database. And I have it right here. So I'm not going to get into too much depth on this, but I will just highlight briefly what they look like. So since we have our product, our category, our images, our vendor, and our cross-reference table, these are all the SQL commands for the generic insert into our tables, all of our update scripts, all of our delete scripts, and all of our select scripts. Now, here for our product vendor, which is our cross-reference table, our script gets a little more detailed. This one I'll go into a little more detail on. Here we have to actually join our select from our product vendor table to the corresponding related tables, being product and vendor. And there we join on the product table's product ID with the product vendor's product ID column, as well as the vendor table with the vendor ID with the product vendor ID columns. And then you have to add a where condition if you want to pull for a specific product ID, a product vendor, or vendor ID. So where is optional, but if you're trying to pull up specific information for either a product or a vendor, you need to add one or both of the conditions. And these conditions actually apply all across all the tables. So you can actually add where conditions for ID, for the vendor ID. So if we were to look at the product, you could add a where on any of the columns in the table or multiple columns. We'll get into more detail on that in the next lesson when we dig more into the code. And the last one here, this one also includes, if you notice, we do the product.star and vendor.star. This tells the SQL script when it sends it to the database to return all columns for that table. If we only want specific columns, we have to list out the columns that we want. Also on the join, unless you give it an alias, you have to use the actual table name, not the column that you want. In case, this is important because in case you have 2 column names that are identical in both tables, this will cause a conflict if you don't specify the product.star or just star. All right, there are many different ways in which we could interface with our database. For instance, we could log into our database console from the command line and run all these scripts. But this can be time-consuming and hard to debug scripting errors. However, I would not recommend using the CLIs for anyone who is a novice or new to databases. Instead, I would recommend using a third-party tool. Third-party tools allow you to interact with your database and simplify the process of sending scripts and communicating with the database. Not only can you run and debug your SQL, but most of these tools offer some form of graphical interface, allowing us to directly put data into our databases similar to a spreadsheet. Some of these tools are DBVisualizer, DBSchema, and Microsoft SQL Management Studio, just to name a few. But before we move on to building an interface, let's take a moment and look at DBVisualizer to connect and interact with our database. Jump back out here for a moment. So this is DBVisualizer. It's a neat little GUI interface. The free version gives you a lot of simple features, which is pretty useful when connecting to most databases. If you want to get the full tool, you can buy a license for it. It's not that expensive. So here's our, my database is MySQL. My the actual database is product catalog. So if I double click on the product catalog, here's the command to create the product catalog. I can then look at the tables that are in my product catalog. So I have category, image, product, product vendor, and vendor. I can also drill down into the actual tables themselves. So here's some information about the table. Here's the columns in the table. And if, for instance, I want to edit the table, I can simply right-click, alter table. There it is. And if I want to add another column, I can just click Add, type in the column information, and I can do this multiple times, and then I can click Execute. Also down here is a SQL preview window to show you the code, the SQL script code that runs behind the scenes. If I were to run this, it would then create all these columns. Refresh my view. Now I have all these columns. Oops, I don't want these columns. I want to fix it, so I can also go back and I can remove these columns. And if I want to go down one more level, I can even go in and enter data. So right now the data set's empty, so I can go in here to my little insert row, and I can give a category ID, other, and there's no parent category ID since this will be a parent category. And then I'll click to insert. Fresh. Save. Oh, there's a problem saving to the database table. So we have a foreign key relationship, which is preventing us from entering in the constraint. So the constraint says the product category product ID has a foreign key relationship against product. So I can't add or delete anything that may already be tied to product. So we'll worry about that one for now, so don't save. But these are some of the nice things that the GUI tools give you that the command line tools throw the error messages up, but they're not really that user-friendly or that easy to find unless you really know what you're looking for. Whereas with these tools, it's pretty much in your face. Hey, whoops, you screwed up. Hey, there's a problem, or everything completed correctly. Now, with that being said, you can still create your own scripts. And one of the things I really like about this is you can highlight the table, you can right-click, you can say script table, and here are all the options you have for creating a script for your database table. So I could do a select on the table, I could do an insert, and an insert then gives me all the information, all the column information. I can then format that, so I don't want product ID because that's my unique ID. I'll drop that one. We'll leave it as category ID 0, name, product 1, summary, t-shirt, a t-shirt, there we go. Summary, cool Dr. Boo t-shirt. And our description, some cool graphic of a Dalek, and we have 10 in stock. So then if I run this, it says one record inserted, so I could then go back into the product table. I can look at my data, and there is my new record. Say, oops, I don't want that. I can highlight the record. I can say drop. Oops, not fresh, drop, execute. Save, and gone. So that's a quick look at using the tools. Okay. Next, what is required to build our interface? So we have three different things we really need to consider before we build our interface. We got to look at software development skills, determine what type of application we want, and picking a programming language to actually code our interface in. So for instance, in order to build software, you need to acquire some knowledge of software development. If you lack the necessary skills to go beyond this step, don't worry. There are many examples on the web, and we have some samples on Developer. With that being said, however, for the rest of this class, we will be assuming you have some programming experience. When it comes to deciding on the type of application, though, there are many different types of applications you can build. Some of the most common types of applications are standalone, web applications, and mobile apps. For this particular lesson, we are going to focus on building a standalone application to connect to our database. Finally, we need to pick a programming language. So we need to decide on which programming language best fits our needs. You can choose between many different languages such as C#, Java, PHP, or any other programming language that supports database integration. In this case, though, we are going to use the Java programming language. So what type of application are we going to build? So here's a simple use case for today's project. Today we are going to build a basic standalone application that will do the following. We are going to open up a connection to our database. We will then insert a record into our database table. We will update the record. We will display the existing record details, and we will delete the record. You can do these in any order. However, the way I actually put the example together, 4 and 5 are flipped because I've actually built a use case that goes all the way through these, and when you're finished, it actually cleans up after itself. So you have a full working test example where it connects to the database, you add some records, you update those records, you report those records, and then we clean up after ourselves by deleting all the records in the table. So let's get started. However, before we begin building out our use case, we need to get a few things first. So to simplify building our standalone application, we will also be using the Spring Framework, which is an open source application framework and inversion of control container for the Java platform, whose core features can be used by any Java application, but they're extensions for building web applications on top of the Java Enterprise Edition platform. A lot of that may not have made much sense to you at this time. That's okay. For now, just know that the Spring Framework is going to be used to help simplify how we connect to our database. In addition to using Java in Spring, we will also be using the Spring Tool Suite. The Spring Tool Suite is an Eclipse-based development environment that is customized for developing Spring applications. It is freely available for development and internal business operations use with no time limits, fully open source, and licensed under the terms of the Eclipse public licensing. And when I switch out to the demo, I'll show you where you can actually download Java and the Spring STS. So to get your Java JDK, you need to go to Oracle or do a Google search for Java SDK. And it'll be www.oracle.com. It's in their Tech Network, Java, Java SE, downloads, JDK 8-downloads, etc. I'll provide a link to the downloads path when I upload this to the site. When you come in here, you need to accept the license agreement, otherwise you can't download anything yet. And then make sure you select the appropriate version for your CPU, your processing chip, or your operating system. So if you're Mac, you want Mac OS X. If you're Windows with a 32-bit processor, you want the x86, and a 64-bit processor, you want x64. Same goes for Linux. If you want to go ahead and get some of the samples, you can download the additional kit down here. It comes with demos and sample downloads. I don't necessarily recommend this unless you're going to be spending a lot of time digging into Java's demos. It's typically faster to just download the development kit and go out and Google some of the specific examples that you want. The other site is Spring STS. And here it's going to be https://spring.io/tools. This will bring you to the download page for the Spring Tool Suite. Be forewarned, if you are on Windows, make sure you click See All Versions. Otherwise, by default, it will install the 32-bit version. If you're running a 64-bit processor, you really need to download the 64-bit version of the IDE. And in order to get that, you have to go to the View All Downloads. All right, I've already installed STS in my environment, so I will go open it. Ask you to open up a workspace. All right, so picking this back up, I've already gone ahead and created a project, but I'm going to walk you through creating a project from scratch, and then we'll go in and we'll look at our pre-built example. So to begin with, you can come in and you can right-click in the Project Explorer and go New, or if you want to create a new project, you can go to File, New, and you can start with the Spring Starter projects. This is really cool because it will allow you to quickly build the basic template for most Java or Spring applications. So in our case, we're going to call this one Product Catalog Demo. I'm going to leave everything else the same for now. We'll get into these settings in more detail in the next lesson, but for now, just take everything by default. Go Next. Since we want to connect to a database, we want to get some of the database plugins. So just type in database, and we're going to want JDBC. There it is, and MySQL. Since I'm actually running a MySQL database, I want the MySQL plugin. If you don't know the database type, you can start with JDBC, and then you can go import the particular driver that you need. Next, and finished. So now this will take just a minute. It's going to go out. It's going to pull down all the dependencies it needs and build the project. And there we go. So we now have a basic project. We have our main application. So this is what we run to kick off our application. We have a resource file for anything we need to add for logging, for properties, whatever. And we also have a test environment that gets built that we can then put in our test cases for unit tests. But for right now, we're going to ignore all those. And we're going to jump back over to the presentation for just a minute. And then we're going to finish up the slides, and then we'll come back and we will finish out our project. All right, so the next few things we need to do in our project is we're going to need to configure the project to use the database. This will require creating a configuration file to store database properties and build a utility class to connect to the database. For this particular example, I've actually combined the two so that they're in the same program. However, for the next lesson, I will have a more defined project with more object and a complete Spring application laid out for you. But for time constraints, I'm keeping this very simple for this presentation. We also are going to want to test our database connection. So we want to create a test class to connect to a database, open a connection to the database, display some database information for your connection, also create a test step that will fail to connect, walk through Maven to run these test cases. Maven is a repository tool and also a scripting tool for Java that allows you to quickly kick off tests, build projects, and other things of that nature. For now, that's all you need to know. We'll get into that in more detail again in the next lesson. Also, we need to go ahead and build out the remaining transaction logic. So we're going to use our MySQL JDBC driver. We're going to then use the JDBC template provided by Spring. This is going to make it very easy for us to create transactions for inserting, updating, querying our data, and deleting our transactions and clean up after ourselves. And then we're going to want to test and create a specific test case to insert a record into our database table. This will insert a record into each of our database tables, product and vendor, capture a new record ID, and use your select method to print out the table record, and also create a test step that tries to insert an invalid record. Repeat the steps for updating and delete. So we're going to essentially cover all these test cases. We'll go as far as we can. We'll start with the product table, and we'll do a couple different tables. And if time permits, we'll create some additional test cases. If not, you should be able to get the gist from the first few examples. All right, so let's go out and build ourselves a project. So the first thing we need to do in Java is, let me jump out to the one I've pre-built, is you're going to want to create class objects for your database tables. And these are essentially going to be a straight mapping to what's in your database. So to create a class, you right-click on the package name, go New, Class. Since I've already done Product here, I'll go ahead and do Category. Actually, let me do Vendor, since Vendor was one of my requirements. Okay, Vendor. Finish. Right now, it's a plain Jane class. So let's go look at our SQL commands. Where's my insert statement into vendor and vendor? You want to try and keep your naming conventions the same. So whatever you have in your database is what you're going to put in your class. These are all going to be class variables, so they are all going to be private. Our numbers are going to be ints. Our strings are going to be strings. Simplify this. Address. Oops. Zip 1, 2, 3, zip should be int. Phone is int. And string. So we now have our class variables. Now we need to make a constructor. This is how we define and access our class. And we will also create a constructor that allows us to pass all the variables in to define them. So we go quickly, you can go to source, generate constructor using fields, click OK. This is another reason why I like using the Spring STS. It has a lot of quick code features for code generation. So now I can go to source and generate my getters and setters. This is how we access our class variables in our object. And we'll also throw in a toString, which will let us write out all the values that are stored in our object. And that's it. So vendor's done. Now we need to create an example to connect to our vendor. So Spring ABC template. Let's do not Spring, but vendor JDBC template example. So in our class, so I've copied our, this was our product class, and I will rename that guy so he's a little easier to understand. that? Yep. All right, so now in our vendor, we start out by creating a connection to our database. So here we're using the MySQL database driver. To get the MySQL database driver, we had to get the dependency for it. Well, when we use the Spring Builder tool of Eclipse, and when we selected MySQL, it already went out and pulled in the dependency for MySQL. The other thing it does is it will pull in the Spring JDBC dependency. The other dependency that we need to add is the Spring transaction dependency. Without this guy, you won't be able to use the JDBC template. So we start out with our connection. We create our JDBC template. We define our JDBC template variable, and then we want to insert into our database. So this is vendor. So we go, again, look at our insert command for vendor. So we copy this. And I'll provide all these, the SQL in when I upload this to the presentation. So now we change all of our types to question marks for variables so that we can pass them in. JDBC template can use straight SQL, or it can also be defined as a prepared statement, which allows you to basically reuse your SQL statement for multiple data objects or a list of objects that you want to update. All right, so this is vendor. So first off, we don't need to update vendor ID. That's going to be auto-incremented, so we drop that one from our insert. But we do need name. So name is going to be a string. Acme Toys. Address. Sunset Boulevard. Suite 400. Daytona Beach, Florida. 37014. I don't even know if that's a valid zip code for Florida, but we'll use it. USA for our country. Our phone, 615-555-5555. And out of range. So we will just do 555 for now. And website, http DoctorWhoStuff.com. And there's our insert record. So there is one record. So by calling the JDBC template update, it automatically passes in your SQL statement with all your variable type, or with all your columns and the values as variables, and then you pass in the variables as secondary parameters in the command. Now, once we insert the record, let's turn around and update that record. So we'll update it with something more descriptive. So for here, we go ahead and add vendor. Nope. Okay. So we'll update. We'll get our update command. Update vendor. Now here, we want to update on the vendor ID. Let's quickly do this. again, you want to change all your default values to question marks so that they now become parameterized. And we don't want to update vendor ID. We actually need to use vendor ID as our where condition, so we update just that particular record. If you leave off the vendor ID, it's going to go update every record it can find in the table, which you may want to do. However, chances are you only want to update one record. And if that's the case, you have to make sure you get the where condition right. Otherwise, you're going to be in for a lot of hurt and find out that you've overwritten a whole bunch of data you probably did not mean to. And our where condition looks good. Now, this is if you want to update all the parameters. For our particular case, though, I'm going to go ahead and comment out that block, and we're just going to update the name of the vendor and the website. So we're going to update it to Dr. Who's Stuff, and I'm actually going to change this. We will change this one to Acme, and this one's going to be the Dr. Who's Stuff website. And the record we want to update is record 1. So we have 1, 2, 3 records that we're updating, so we need to have 3 parameters. So that's your update statement. So to update, again, you call JDBC template update. Now, in this particular case, we're using our update script. However, update works as both an insert and an update tool. If you are passing in an insert command, it will go ahead and insert that record. If you pass in an update command, it does the same thing. The biggest deal with this is if the record does not already exist and the primary key is an auto incrementer, it will go ahead and insert the record for you. Next, now that we have inserted our record and updated our record, now we want to pull that record out. So what we can do now is we create a simple select star from vendor, and then we want to receive a list of products. But when we do a select from vendor, this builds us a result set. Well, our program doesn't know what the result set is, so we have to tell it what format to convert the result set into. So this is kind of like the mapping feature that the tool does for importing and exporting of data. So we create a inner class and call it map row, which takes our result set from our query and row number. And then we can do product. So we'll define our product here. And then we define all of our, well, actually, in this case, we want vendor. So I need to update this to vendor. Vendor. Return vendor. You know, like that, yeah. Vendor. Now we need to do vendor dot set vendor ID. And we want to pull our vendor ID out of our result set. And that will be an int. And that's going to be vendor ID. Let's see here. Oh, 1 too many parentheses. Nope. Oh. Okay, so vendor.set name. Result. Get string. Name. Set name, address, there's 2. To the state. Zip. And what else? We have country and phone. Country. And our phone. So now we know we're going to be doing results. Got string. C, paste, 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 paste. Right, so that's name. This 1, this 2, city, state.
We're about 45 in.
Yep. I'm only doing this one use case, so we're good. Thank you. Okay, int. Zip. Result. Get int. Phone. And we now have vendor done. So we now are pulling and mapping. So when we run our select, we get all of our the result set from our query. We then map that to our vendor object, and we create a list of vendors. Now we can actually loop through those down here. Vendor. And list of vendors. And when we're all done, we want to delete from vendor, where name, actually, I will do that instead of 1, where name equals, actually we'll do zip in this case. Zip is that. Okay, so quickly to recap, we set up our configuration to connect to our database here. We then define or create our connection to the database using the JDBC template. With the JDBC template variable and class, we can call update to insert and pass in our insert. We can call update and pass in our update script. We can also call JDBC template query, which returns a result set, which we can then map to our vendor objects. We can then loop through our vendor objects and print out what's in our vendor classes. And then we have the string SQL delete from vendor where zip equals our zip code that we added. And we call JDBC update and pass in the delete. And if I run this guy, if I did everything right, which I didn't. I did something wrong. So as you can see from it starts out, it tries to execute the prepared SQL, creates the insert statements, it ran the update, But then when we got down to the update, it found a problem. I have a nested exception. So this is what happens when you screw up. So you will see a nice red exception error, and then it, oops. And then you can walk through and figure out where it blew up within your code. So let's see, Spring MySQL, Java Reflection, Spring Java Core, 4 more. So it's pretty straightforward. I screwed up right here, line 47. So it's saying this guy is bad, which means I did something wrong here. Chances are it doesn't like that. So we got name, website, zip code, set that. Oh, I lost my comma. There we go. Say that guy one more time. Try to rerun it. And this time we looked. So it ran the update, ran the insert command. Then we come down here, and here is our select statement. So we have 2 records out there. So we have vendor ID 1, 2, Dr. Who Stuff, 100 Boulevard, 400, Daytona Beach, Florida. And the website is null because I'm deleting just the website. So if I want to actually delete everything, so just delete vendor, we can drop that and just leave the command. We run that puppy. And now if you look, we have 1 record. So now every time I rerun this, we'll have 1 record. I seem to have lost my website though. It is updating Dr. Who Stuff because we did start out with Acme. To prove that to you, we can copy this. For simplicity's sake, we'll just copy it for now. Actually, what I'll do is I'll comment out the update, and we'll leave it as is. Rerun that guy. So now if we look, we have vendor 4, Acme Toys, address 100 Sunset Boulevard, yada, yada, yada. So that meets all of our test cases. We have a connection, we have our insert, we have our update, we have our delete, and we have our select. And we also have one for product. So product also, I defined the product class and the data object for the product, and the product has the exact same methods, or the exact same logic. We connect to the database, we insert our product, we update our product, we select our products, and then we delete our product. Just do the straight up delete. And then if I run, go, and run this guy, and we have the same thing. So now we have created a product ID 2, inserted him in, and then we deleted him from the database. And then the reason we use the data source, so this is one of the reasons why we use JDBC template. JDBC template creates the connection to the database. It manages the database connection for us. And then when it's all done and the program closes, it closes the connection to the database. Quickly recap. So today we looked at the different ways we can manage our data. We can use the command line interface tools, we can use third-party tools, or we can create our own Spring application to interface with our database and simplify the process of inserting and updating our products in our product catalog. In the next lesson, we will dive deeper into the Spring Boot and Spring MVC tools. We will look more at the Spring framework itself and things like the Maven dependencies, some property files, and some other things behind the scenes within Spring. We will then continue to build our application up till we have a web application using the Spring MVC framework. We will do this in stages. We'll probably move our application further along to make it more functional, and then we will flip it over and make it a Spring MVC application. Then once we have a fully functional application that can interface to our product catalog, I will show you how to create a web site based off of that, that you can pull the data from the database and basically present your product catalog dynamically on a website. Finally, we will then jump to building a reporting tool that will allow you to keep track of what's in your database, kind of an inventory tracking program. Plus, you can do reporting on how many products you've sold, products in inventory, out of inventory, and things of that nature. Thank you for your time today. Send any questions, comments, or requests for assistance to info@developanerd.com or contact us via the site. At this point, do you guys have any questions?
Yeah, I got a question. So this one, pretty much you are showing us what is done behind the scenes, or is it, was it like connecting to like a real database? Because I was looking at the code and I wanted to see how it updates the database, but I was wondering whether we are connecting to like the real database or it's like something like behind the scenes stuff.
Nope, it's the real database.
All right, so this is where we're actually connecting to the local database. So I'm using the MySQL driver. There's the URL and the database, my username and password. And then by using the insert, update, and query, that's actually hitting the database. So it inserts, it says connection from data source, and it creates a new connection to my local database product catalog. So when I run this again, because I removed the delete, I should get a second record, which you see here. And then if I go look at the database, I now have a second record. So does that answer your question, Dave?
Oh yeah, it does. It does. Yeah, I can see.
Since there are no other questions, we will wrap it up here. Everyone, have a great day.
No, I'm good.